All right, kind people. Um, Today we're going to be looking at foundations, three linear functions. A linear function is a function that can be written in the form um, um, y equals mx plus b, or f of x equals mx plus b. They're called linear functions because the graph is a straight line. And what we have right here is the y and x are raised to the first power. When we have that happening, we have what's called a linear function. The graphs of a linear function basically either look like a line that's growing, a line that's decreasing, a line that is horizontal, or a line that is vertical. And so those are basically what your graph of your linear function look like. The type of graph that you get is based upon the values of b and m. Those are our two parameters. M is called the slope, while b is the y-intercept. We'll look at the y-intercept first because it's kind of obvious why it's called the y-intercept. The y of a linear function. So if I have a function y is equals to 3x plus 10, to find the y-intercept, we simply set x equals 0. We always set x equals 0 when we're looking for a y-intercept. And in doing so, we will always get y is equals to 0 plus 10. Therefore, y is equals to 10. Thus, the y-intercept is 10. Or if you prefer, you can write it as 0, 10. And because this part will always zero out, you will always be left with the 10, and that's why it's called the y-intercept. It's just a physical fact of plugging in 0 that you'll always get that second number as your y-intercept, and that's the name of the y-intercept. The slope, on the other hand, is actually a little bit more difficult to explain, and so we will try to explain the slope in several different fashions. Consider the equation y is equals to 3x plus 2. If I was to make a table of values, let's get all fancy. Let's go left to right. -2, -1, 0, 1, 2, 3, 4. Now, of course, to create a table of values, you take the independent variable. In this case right here, -2, and you plug it in. And when you calculate that, you get -4. -2 times 3 is -6. -6 plus 2 is -4. That gives us the y coordinate. We keep doing this. -1. Of course, the y-intercept is 2, 5, 8, 11, 14, 17. The thing is, there is a pattern to these y values, and that pattern is very simple. If you look at the y value, to go from -4 to 1, I have to add 3. To go from -1 to 2, I have to add 3. And I will keep adding 3. And thus, where does this 3 come from? This 3 comes from the number in front of x. As x goes up by 1, the total value goes up by 3. And that is your first definition of the slope. The slope is the change in the y value every time the x value is incremented or increased by 1. By 1. That leads to a very special kind of graph. If you keep increasing the x values by the same amount each time, you end up getting what we call a line, as you will see later. Based upon this definition of the slope will determine whether the graph increases, decreases, or is constant. Also, when we have a vertical graph, the slope also has a role there as well. Quite simply, if the slope is positive, it means the y values are getting larger. If the y values are getting larger, then the graph must be growing. If the slope is negative, that means the y values are getting smaller, which means the graph must be decreasing. If the slope is 0, then the y values will not change, and the graph will be horizontal. The y values are constant, and so we call that a constant graph. There is one special time, and that is if the graph is going straight up or down, then there is no slope. The slope is undefined. The slope is undefined in this scenario right here. We'll get to that a little bit later on. This right here is what we would call a vertical line. The next definition of the slope is the slope as your rise over your run. Now this right here is the classic definition of the slope, and the one that most people are accustomed to. Here, the slope is given by the change, or the delta, in y over the change in x. And that is physically done by subtracting the two corresponding y values and then dividing by the subtraction of the two corresponding x values. Your y values represent the change in your height and thus your rise. The x values represent the change in the change in your I guess vertical, horizontal, the left or right position, and thus your run. And so remembering the idea of rise over run helps you remember that the y's are in the numerator and the x's are in the denominator. So, as an example, if I have a graph of a function that looks something like this, and the graph goes through this point right here with coordinates 1, 4, and coordinates at this point right here 6, 8. By the way, because of the nature of lines, all you actually need are 2 points to understand everything there is to understand about that line. I can calculate the slope of this line. The slope of this line will be given as the change in the y values, that is 8 minus 4. If you think of this as being y2 and this as being y1, over 6 minus 1. Again, think of this as being x2 and this being x1. x1 and y1 are always on the same point. x2 and y2 are on the same point. And you could flip. You could have made the 6 and 8 x1 and y1 and the 1 and 4 x2 and y2. And that will not change the outcome. Anyways, 8 minus 4 is 4. 6 minus 1 is 5. And so this graph right here has a slope of 4 over 5. Another way of stating this is that we rise 4 units every time we run 5 units. And so if you look at your x1 coordinate and you add 4, that will give you your x2 coordinate. And if you take your y1 coordinate, oh, that's backwards actually. If you take the x1 coordinate and you add 5, that will give you your x2 coordinate. And if you take your y1 coordinate and you add 4, that will give you your y2 coordinate. There we go. The nice thing is that the slope is a constant for all lines, and so therefore I can automatically find the next point on this line. The next point, according to the slope on this line right here, would be the point where I would have to add 5 to the x values. So therefore the x coordinate would be 11, and then I will have to add 4 to the y coordinate, and so the y coordinate will be 12. You often see your teachers graphing lines this way, by simply taking a single point and then using the rise and the run to find another point on that line. And once you have those 2 points, like I said, that's enough to graph the line. You can actually do this backwards, of course, and then go 5 units and then down 4 units. And the coordinates for this point right here would be, I am subtracting 5, so that's -4, and then I am subtracting 4, and so, oh, that would be 0. So the point actually should be over. The point should actually be here. I guess I should say not drawn to scale, but that would be a 0 right there. Down 4. So let's clean this up a bit. You need to go further across and then down 4. There we go. But that's the power of understanding the slope. Once you know how they point and the slope, that's enough for you to get the graph of the function and also the equation of the function. equations. Now, finding the equations of a line is often the most challenging part of this section, and the main reason is that there are about 25 million different questions they can ask. All of them saying, find the equation of the line. And so you have to go through and practice and be careful when trying to find your equation of your line. So let's start with a simple example. Find the equation of a line through the points 2, 5 and 4, 9. Well, first things first, as we discussed earlier, the equation of the line can be written in the form y equals mx plus b. And what I normally do is I always think of a Mercedes-Benz. Mercedes-Benz starts with an M followed by a B. Mercedes-Benz, get it? Mercedes, no? Oh well. But the thing is, you tend to want to find the slope first, the Mercedes first. And after you find the slope, then you can go ahead and work on finding the y-intercept. And of course, the slope is given by y2 minus y1 over x2 minus x1, which is 9 minus 5 over 4 minus 2, which is equals to 4 over 2, which is equals to 2. And once I've calculated the slope, it becomes a pretty simple step to find the b. I know that my equation is y equals mx plus b, and I know that when y is equals to 5 and x is equals to 2, the slope is 2 and b is an unknown. The y value comes from the point right here. The x value comes from the x coordinate right here. And of course, your 2 is your slope, which we just found. Now that we have all of these happiness and joy right here, algebra will take us home. You know, algebra, your best friend in the whole wide world. 2 times 2 is 4 plus b, and you subtract 4 from both sides of your equation. And so you get that 1 is b. So your y-intercept is 1. And so therefore my equation is, y equals 2x plus 1. What happens is you leave the x and y values as free variables. You leave them free. And when you're building your table of values or whatever, you choose your x, and then that'll give you your y value. And so all you need to do is put in your parameters of your slope and your y-intercept. There's a different way of solving this problem right here, and it's done by using a different equation of a line. That equation is called the point slope of a line. Form FORM. Remember, the slope is equals to y2 minus y1 over x2 minus x1. This is a fraction. This is an equation, so I can multiply both sides by the same amount. Let's multiply by x2 minus x1, and then let's multiply by x2 minus x1. What happens is that the x2 minus x1's cancel, and that leaves me with this equation. x2 minus x1 times the slope is equals to y2 minus y1. Now if I drop the 2's and I rearrange it slightly, if I drop the 2's and I put the y's in front, y minus y1 is equals to m times x minus x1. This gives us the point slope form of line. The point slope form of a line is when you're given a point and the slope. In the previous question right here, Once I have calculated the slope, I have a point. I could use the point slope of the line to finish the problem. So the problem would say, find the equation and then they'll tell me that the slope is 2 and the point, I forget what the point was. The point was 2, 5. And the point was 2, 5. Once you have the point and the slope, you can use the point slope formula equation, which is y minus y1 is equals to m times x minus x1. Simplify, y minus 5 is equals to 2x minus 4. And then add 5 to both sides. Plus 5, plus 5. And so I get then that y is equals to 2x plus 1. The same answer we got before. In my opinion, the point slope form of the line is a little bit simpler than finding b directly, like we did right here. And you get the answer straight away. You get the y equals 2x plus 1. And so that has its advantages. But either way, you get to the same point and the same place. Right? Doesn't that make us happy? Yay! Yay. Now, there are two special cases that we have to be careful of when trying to find the equation. The first is what we call horizontal lines. The second is your vertical lines. Let's go ahead and tie some things together. First things first. Your horizontal line always ends up being y equals b. But why? Well, b is any number. They are also called constant graphs because the y doesn't change value. Let's look at two examples. Let's say I have the line y is equals to 3 and I'm trying to graph this line right here. The line y equals to 3 is simply a horizontal line that goes through the point 0, 3. Horizontal lines have one simple fact. Every single point on your horizontal line will have the same y coordinate, which is one of the reasons for the name. Y is 3. Y equals 3. Y is 3. And so therefore y is always 3. If I try to find the slope of the horizontal line, y2 minus y1, let's make that 3 look a little bit better, divided by x2 minus x1, I will get an answer of 0 divided by a negative, and a negative become a positive over 9. But 0 over 9 is 0. Horizontal lines always have a slope of 0. And because they always have a slope of 0, well, the reason is because the y values are the same in the numerator. When I subtract them, my answer will always be 0. And thus the fraction of 0 in the numerator will always be 0. Yeah, I think I've seen this on the internet. If you have 0 over a number, that's okay. That's fine. But you cannot divide by 0. That's undefined. Always remember, okay, 0 divided by a number is fine, but n divided by 0, a number divided by 0 is always no undefined, like so. And so you have your slope right here. You have your 3 minus your 3, that gives us the 9 over 0. That's undefined. And so, if I know the slope, and I have a point, if I try to find the equation of the line, y minus y1 is equals to m times x minus x1, what will always happen is that the zero will cancel out. The zero slope cancel everything out. And so all you'll be left with is an equation with y only. So y is equal to 3. And that gives us our horizontal line. And that's why our equation is always y is equals to a number for a horizontal line. The x part of the slope, y equals mx plus b. This m is 0, and so it gets cancelled out. And so you just have y is equals to a number. So whenever you see y is equals to a number, say 3 or 10 or 500, you automatically have a horizontal line. Let's go ahead and summarize all of this right here. It's a nice little mnemonic. I think they're called mnemonics. Who knows, right? H, O, Y, Y. Horizontal lines always have 0 slope. They always go through the y-axis. And they only have y in their equation. So if you see y is equals to 10, this is a horizontal line because there is no x in the equation. It is a line that goes from left to right. Oh, I get all the way down here. It is a line that goes from left to right. Similarly, we have vertical lines. Vertical lines feature an equation with x on it. There are lines that go straight up and down. And whatever the x coordinate is, it never changes. So if this right here is 4, then this point up here will be 4, 10. This point down here will be 4, -5. The point being always the same. If I try to find the slope, something bad will happen. y2 minus y1 over x2 minus x1. I will get a division by 0, which is undefined. Because it's undefined, the equation right here, that's why the slope is undefined. When you have a line that is going up and down, those right here are the vertical lines. Those are, as we say, undefined, 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 undefined. And that's, if you see an equation where you have x only, no y's anywhere, that is a line that's automatically going up and down, up and down. Okay, so a nice little way to remember this right here is VUX, X. Vertical lines have undefined slope. They go through the x-axis. And they have x only in the equation. That should make it pretty easy for you to identify vertical lines. Along with your vertical lines and your horizontal lines, we have two special kinds of relationships between lines: parallel lines and perpendicular lines. Parallel lines are lines that have the same slope. Remember, the slope determines if the graph's increasing or decreasing, and how quickly it's increasing or decreasing. So if I have two lines that are increasing at the same rate, the two lines are parallel. So if I call this one L1, line 1, and this one L2, line 2, then we say that L1 is parallel to L2, and that would immediately mean that the slopes of the two lines are exactly the same. Parallel lines have the same slope. If you think about it, horizontal lines, all horizontal lines, the slopes are 0. So therefore, all horizontal lines are parallel to each other. Vertical lines, technically, they have the same slope. Well, they're undefined, so they have the same rationale behind the slope. On the other hand, we have perpendicular lines. And perpendicular lines are lines that meet at a right angle. So 1, 2, my first line is heading this way, and my second line is heading this way right here. And the two lines meet exactly at a 90-degree angle. We will say that line 1 is perpendicular to line 2. And in this case right here, the slopes of the two lines, M1, is equal to the opposite reciprocal of the other line, M2. Another way of saying that is if you multiply the two slopes together, the answer will always be -1. And when you have that right here, you have two lines that are perpendicular to each other. One last thing, so if you have the first line has a slope of 2/7, then the second line will have a slope of -7/2. The nice thing about this right here is that it's easy to, once you have one, the second one is pretty easy to find for your two slopes. That actually makes it very easy to draw two lines that are right angles to each other. So if I start right here from the center, if my first line right here has a slope of 2/3, that means starting from the center of my first line, I will go up 2, and then over 3, 1, 2, 3, so up 2 and over 3, that give me this point right here, and my line will go this way right here, that is L1, and a perpendicular line will automatically have a slope of opposite, the signs are always different, and reciprocate. And so therefore, my line will again start 0, 0. This time I'll go down 3, 1, 2, 3, and then over 2 right here. If I draw this line carefully, this is a nice way by hand drawing a right angle. These two lines will automatically meet at a right angle. Alright, this is the first half. The next half I will go through and I will do several examples involving solving equations of lines. Thank you. Have a lovely day.